Welcome to the third virtual office hours for the 2014 POSA MOOC. As you know, if you've been following along, this is an opportunity for students in the class to ask questions, for me to get a chance to go over the solutions to assignments. We'll be going over the assignment for week 2, assignment 1 today. I'll show you my solution and talk about a couple of different alternative ways of doing things that are good, and we'll also talk about some ways of doing things that maybe aren't so good. And we'll also talk about the following assignment, which is, I think it's week 3, assignment 2, and that's the assignment that deals with simple semaphore. So I'll kind of go through the assignment, explain what it's asking you to do, and answer any questions there. We'll also have a chance to answer your questions that you ask live. I see lots of them are popping up. That's great. I will get to those in just a second. And another thing that we will probably do is go over and I'll answer any questions that are on the virtual office hours discussion board, and that's a good place for people to leave questions if you can't actually join us live. We have, looks like, about 60 people joined so far. We'll probably get a few more here. As is always the case, I will take this video and I'll do a little bit of post-processing to make it look a little nicer, and then I'll go ahead and post it up on my YouTube channel and on the Coursera website so you can download and watch it at your leisure. First, just a little bit of demographics and statistics for you. We have about 75,000 people enrolled in the course now. That's gone up quite a bit over the past couple of weeks. It's people from about 200 different countries, which is amazing. And right now, the most number of people percentage-wise are coming from Europe. I think it's about 32–33% of the class is from Europe, about 30% of the class is from the US, and then it breaks down in all kinds of interesting ways after that. So we really have a very, very international group, and that's fantastic. It illustrates the fact that people all around the world are interested in these topics. Okay, so what I wanted to do to start out with is show you my solution for week 2, assignment 1, and then I'll take questions related to that. So let's go ahead and see if we can do a screen share on that. I will bring up my editor, which is good old trusty GNU Emacs. Naturally, you can use something besides GNU Emacs if you want. You can use Eclipse. I use Eclipse also, but GNU Emacs is somehow what it always comes back to me. I always love using GNU Emacs. So let's go ahead and switch over to the assignment for week 2. Here is the actual implementation. So keep in mind a couple of things. First of all, this is one way to do it. One of the things you learn from taking this class is that there's lots of different ways to solve the problem correctly, and there's even more ways to solve the problem incorrectly. Hopefully we'll be spending most of our time doing things correctly, but one of the things I always learn when I read the discussion forum is just how many times people get confused by certain things. So we're going to talk about a lot of the confusions as well as hopefully some ways to do it right. So first, let's take a look at the solution. So here you can see simple atomic long. Let me do everybody a favor and make the font just a little bit bigger because it's a little bit hard to see probably, especially on the video. There we go. That's probably a little easier to see. That's 16 point. So here is the first thing that you had to do. You had to implement the reentrant read-write lock. And as you can see, it's pretty easy. You just say new reentrant read-write lock, and that's about all there is to it. It's a final data member, so once you assign it once, you're done. Let's look at the constructor. Lots and lots of questions about the constructor this week. I'm going to talk about some of the subtleties involved here. This is what your constructor looks like. Now, a couple things to note. Notice that the parameter that's passed into the constructor is called initial value. It is not called max value. It's the initial value. And this is a cause of a lot of confusion. The way that semaphores work is you can give them an initial value, which is the count that it starts out being initialized to. And then if people want to decrement by doing acquire, they'll keep going down until you get to 0, at which point you block. If people want to release, then normally you would release as many times as you had acquired, but there's nothing to stop you from trying to release more. So this initial value can grow and grow and grow. And that may seem counterintuitive at first, but that's the way that Java semaphores work. And so our simple semaphore implementation is just doing the same thing. You'll also notice that there is no lock involved here at all. We aren't trying to acquire and release a lock in the constructor. That is unnecessary, and I will talk later about why it's unnecessary, and I'll talk later about why it's subtle that it's unnecessary, but you don't need one. If somebody chose to use one here, I wouldn't take any points off. They're just having an abundance of caution. If they wanted to acquire and release the lock in the constructor, they're welcome to do so, but it's not going to, it's not really strictly necessary. All right, so let's go down here and take a look at the get method. Now, as you'll see in a minute, there's a bunch of different ways to implement this stuff, and I'm going to show you the way I did it when all was said and done. I had a couple of alternative approaches. I will show them as well, but this is what I did. I came in here and I grabbed, this is the get method. The get method is basically an accessor that gets the value back, and it, as you can see here, it grabs the read lock and it sticks it into a final local variable called lock, and then it acquires the lock outside the scope of the try finally block. It then comes in and it returns the current value, and then when it leaves, no matter how it leaves, in this case it's going to leave only one way because there's no chance for exceptions here, the last thing it's going to do is it will always unlock the lock. So this try finally idiom is something that you see quite frequently when you're dealing with Java locks, when you're doing them explicitly. Okay. Now, so this is how my get operation works. The idea here, by using a read lock, is we want to be able to allow multiple threads to simultaneously read the value of the simple atomic long. So that's why we use a read lock, because reading is something that should be able to go in parallel. Lots of things can read at once. Some of you noticed that reading is a little slow, and there's reasons for that. We'll talk more about those shortly. So this is one way to do it. This is not the only way to do it. Another thing you could do, which would be perfectly fine, is not to do this, but instead you could say mrw lock dot read lock dot lock. So that would be a perfectly acceptable thing to do as well. You wouldn't, in that particular case, need to create a lock. You would just basically update these things like this, and your code would look like that. So if somebody has a solution that looks like this, that's perfectly fine as well. There's other things you can do. Let's stick with the way I did it, just for fun, just to make it concrete. Another thing you can do, which is how I started out doing it, would be to say long value, which I don't necessarily have to set to anything, just say long value. And then I can come down here and I could say value equal m value, return value. This is also a perfectly reasonable thing to do. In fact, if you look at the original code that we had, if you take a look at the code here, before we did all that, that's pretty much exactly what the Java compiler is generating. When you have this code here, the Java compiler under the hood is actually generating something that looks probably something quite a bit like this. It's going to create a register or a value of some kind. It's going to acquire the lock. It's going to copy the value that needs to be protected into this local value, releases the lock, and then it's going to return the value. So those two solutions are basically identical. Keep in mind the semantics of atomic long or atomic int. They're just to make sure that the values are updated atomically. They give you no transactional guarantee that the value you get is guaranteed to be the freshest value. Because of the way the concurrency works, by the time you return the value, it may already have been updated, but you will always get back an atomic value that's atomically updated, and you won't end up with two threads getting the same value if they do increments. So it's done atomically. So either of those two approaches are perfectly fine. Now, and I think so. We actually see three variants right now. There's yet another variant we could have here, which we don't do in this case, but it would also be acceptable. You could say volatile long, and then down here you could change this to basically just say return m value. And because we make it volatile, in that case there's no need to acquire the lock because we're just returning the value. And volatile basically says don't cache this value, push it through the memory caches, and make sure it's propagated to everybody in an atomic way. So that would be another way to go. That's not what we chose to do in this case. And the reason we didn't choose to do it this way because I wanted to have you learn how to do reader-writer locks. But you could do it that way, and in fact, that's the way that the Java atomic long and atomic int actually work. They actually use volatile values, M values. Now, let's talk about some things that you shouldn't do. So one approach, which seems actually quite appealing at first glance, is to do something like this. Synchronized MRW lock read lock, return M value, and then stop the synchronized block. When you first see this, you think, wow, that is super duper cool. This is awesome. Now I don't have to do these stupid try finally blocks that are confusing and have strange semantics and are obtrusive. I can just go ahead and wrap this thing inside a synchronized block. Unfortunately, this doesn't work properly because it's not doing what you think it's doing. Instead, it's acquiring the monitor lock on the read lock object, which is not the same as acquiring the read lock on the read lock object. And if you take a look, there's actually something on the discussion board from earlier today that talks about this and explains why it's not going to work the way you want. So I sure wish it worked this way because it would make your code really super concise and I think more clear and understandable. But unfortunately, that's not the way that the semantics of synchronized blocks work in Java. So this code wouldn't actually work. It actually would work, but it would over-synchronize because it would use a write lock where you really wanted to use a read lock. By the way, a lot of people have pointed out that the try finally syntax and semantics are confusing, and I couldn't agree more. As a long-time C++ programmer, I find the absence of destructor semantics somewhat confusing in Java, and this is a good example of where having destructors would help out quite a bit because you could use the scope blocking pattern, you could use resource acquisition, is initialization idiom. That's very common in C++ code, and this whole thing would just turn into one line or two lines. But anyway, that's the way things work. So that's get. Let's go down here and we'll take a look at the other operations. All the other operations, decrement and get and increment and so on, all use write locks. The reason they do that is because they want to be able to modify the value. And to modify a value, you have to make sure that only one thing at a time is happening. Otherwise, bad stuff will occur. So here's what we do. We come in. Notice how the actual structure of the code is almost identical, but we just use a write lock instead of a read lock. And that allows us to be able to do operations with side effects, like decrementing the value by 1. Hopefully you all know that minus minus m value and m value minus minus are different operations. One is pre-decrement, the other would be post-decrement. And they basically both need to be done atomically, but they're going to return different values and have different side effects. And the documentation explains what they do. Let's see. Trying to think of a couple other things that we could talk about in this context that were confusing to people. So a lot of people were trying to do stuff where they would first acquire the read lock, the write lock, and then they would go ahead and release the write lock, and then they would go ahead and acquire the read lock. And their code would probably look something along the lines of this. I didn't write code like this, but some people did. So they might do something like, let's see, minus minus value, unlock the lock, lock equal MRW lock, read lock, and then they would say try, let's see, long value equal m value, and then they would say finally lock unlock, and then they would say return value. So you can see what they're trying to do here is they're trying to do write lock semantics to modify the value, and then they're trying to do read lock semantics to read the value. There's just one big problem with this approach. Between the point where the lock is unlocked for a write lock and the read lock is locked for reading, another writer could come along and change the value of m value. And so you'd end up getting the new value of m value. And there's a very nice discussion on the discussion forum from today where someone did a good job of going through the details of how this could cause problems. So if people did this code is wrong. This will not give you the right values. What people might think that they're trying to do is something called write lock downgrading to read locks. And just to give you an illustration of this, let me go over here for a second, and I will bring something up for you, and I will show you what people think they're doing, and we'll take a look and see what it is that they're actually doing. Let's see, I think, where did it go? It's one of these guys in here. Maybe it's this one. Nope, that's the wrong one. Let me go find the, there we go, this is the one I want. All right, so let's switch screens. Yeah, there we go. All right, so if you go to the discussion forum, there's a whole thread talking about this issue about read locks and write locks. So I actually wrote an example to illustrate how you could do read lock downgrading. And this is the way the read lock downgrade code works. Hopefully you can see it. I'll enlarge it a little bit so you can look at it. So this is increment and get done with a read lock downgrade. So we come in, we acquire the write lock, we lock it, we increment the value. We then go ahead and downgrade the write lock to a read lock. Then we go ahead and read the value. Then we unlock the write lock, and then we unlock the read lock. And if you read the article that's referenced here, it explains to you why this works properly. But my goodness, number one, this code is going to be really inefficient. Number two, this code is really hard to understand. And so for the particular example we're doing, it's completely overkill. But this is how you could properly do read lock downgrading. Now, there was a real good question asked earlier by Dean, I believe it was, Dean Schultz, who said, what would be the circumstances under which you would end up using read locks? And the bottom line is, read locks work best when you have lots of threads and lots of cores doing lots of read operations. That's when it's a win. If you have a few threads and a few cores and few read operations, then read locks are probably massively overkill, and so I would recommend avoiding them unless you really know what you're doing. Okay, let's pop back over here again and bring up Emacs, if I can find it. There we go. Okay, so all these things look pretty much exactly the same. So the code is pretty much identical for all the different things. Now, one thing that you can also do, the following is also correct. There's no problem at all for this particular example to remove the try finally blocks. So if people wrote code that looks something like this, that code is perfectly acceptable. All that's happening, oh, I'm sorry, actually that code is not perfectly acceptable. That code is perfectly horrible. This code is perfectly acceptable. Something like this. Long value, return value. This code is fine. And the reason that it's fine, whoops, I guess you could actually do this if you really want it to be more concise. So this code is fine, and the reason for this is that incrementing a variable with plus plus or minus minus that's a long will never throw an exception. So we don't actually have to worry about try finally. That's unnecessary. Now, why would you choose one approach versus the other? Well, if you're sort of a C++ programmer, you might fret a little bit and think, oh my gosh, I've got a try catch or try finally block in my code. That means it's going to be bigger and slower. That's a bad thing. And you might be right in C++ compilers. My hope is that a Java compiler would optimize this overhead away entirely when it realizes there's no exceptions that can be thrown. But maybe there's some overhead. So if you're really concerned with overhead, this code is fine. I prefer to use the try finally approach for a couple reasons. First of all, it's more idiomatic, and I don't do dumb things. Like I don't do stuff like this, right? This is a classic example of a dumb thing to do, where I accidentally return here and then I unlock. Well, that's not going to work very well, right? So I prefer to use the try finally approach in Java, even if it might be infinitesimally slower, just because I find it easier to understand, and if I have to maintain this code and evolve it and explain it to people, it always works the same way. But if somebody didn't want to do this, if they wanted to do it the other way, for this particular example, it's perfectly fine. So don't take any points off if they chose to do it that way. Pretty much everything else people might be doing probably has a bug with it. And so what I'm going to do now is I'm going to switch over and get out of the editor mode and go back to the screen here and start answering questions about this stuff. Okay, so let's see. Here's the first question, which comes from Benzenko. It says, the evaluation of week 2 assignment 1, it does not matter whether try-finally blocks are used or not in the solution as long as the synchronization mechanism is correct. But what does correct synchronization mean in this context, or in this case? Well, hopefully, Benzenko, you now have seen some nice examples of what it means. It means that you make sure that you properly protect things that change, so they change atomically, and that you make sure that things are properly fleshed and flushed out to caches by using the appropriate locking mechanisms, read locks and write locks. That's what that means. You don't have to use try finally, as we saw a minute ago, but of course you have to make sure your code works properly, and you always release the lock no matter how you exit. So hopefully that answered that question. Let's see. Oh, here's a great question. This question is from Wah. I find JUnit tests are not very reliable. You are absolutely correct about that. And I lack the knowledge to determine if a solution is correct or not. Well, hopefully after watching the video of my solution, you'll be in a much better position to take a look at the code that you're reviewing and give it feedback and evaluate it. So if you have questions, of course, continue to post them. And lots of people are spending a lot of time on the forums providing tips. I really appreciate that. That's fantastic. By the way, I was just talking to Professor Bill Shirless from Carnegie Mellon University, who is an expert, one of the world's experts in static and dynamic analysis of concurrent programs. And he has a tool called Fluid, F-L-U-I-D, which I actually reference in some of the early videos on race conditions. And he and I are planning to team up with his company called SureLogic for the next offering of the MOOC to try to do some integration of their static and dynamic analysis tools for SureLogic with the assignments that we're doing. And that will allow people to get free evaluation copies of their tools, and we'll be able to do much more thorough analysis to see whether or not the code is correct. Now, as you've seen, even when you have these kinds of tools, it's still possible to do something completely insane that will throw the tools off. And so that's why it helps to have smart people reviewing the code. And it's also helpful for people to review code because they learn common mistakes that people make with concurrency, synchronization, scheduling, and so on. So I don't know if we'll ever be able to get completely out of using peer assessment, but we'd sure like to be able to make the automation of the regression test much more painless, much more seamless, much more accurate. And so next time we'll be able to do that. Let's see, next question. And by the way, I appreciate people who are contributing enhancements to the JUnit test. That's a real great contribution. Will the with the write lock block, will they block indefinitely, or is that a lockdown grade? John, I'm not quite sure what your context is. You probably asked it while I was in the middle of going through the example. So if you acquire a lock, then until you release the lock, that will be held. And so you have to make sure that when you acquire and release locks, the operations you do will not run for a long time. So maybe what you're asking is there an opportunity for starvation, where if there are endless writers, a read lock will never get to run? And the answer, of course, is yes. And every implementation of readers-writers locks has to figure out who it's going to give preference to, readers or writers. And so if you take a look at the Java documentation for reentrant read-write lock, you'll see how they handle that. Here's a good question. Is there a reason not to put the lock inside the try? Yes, because we don't want to have to catch an exception in this case. The key exception that we care about would be the interrupted exception. And by default, if you just call lock, you don't get interrupted. So you just keep blocking until the world comes to an end. If you use lock interruptibly, then you can be interrupted. And you want that to throw an exception. You want that exception to be propagated out of the scope. And so by not putting the lock inside the try, we don't have to worry about putting a catch in there. And as you can see, we actually didn't use a catch at all. We have a try finally block where finally does the cleanup no matter how you exit that scope. Let's see. Is it possible to upload the solution in GitHub? We're not going to put the solutions in GitHub for a variety of reasons, but having just taken a look at this on the video, you should be able to figure it out pretty quick. It just requires some diligence. I don't want to make it overly easy for everybody in the world to copy this stuff. Why do you create a local lock variable? Let's go back over to the example and talk about what that is. So here's what the question is. Why do we do this as opposed to doing this? mrw lock, right lock, like that, and then mrw lock, right lock, unlock. So that the question basically is why do we have this thing? Well, honestly, reasonable people can do it either way. So I don't really care which way you do it. I happen to do it this way because I think it looks a little bit neater. It just is less visually jarring to my eyes. Your eyes may see things differently. That's fine. There's also some folklore that says that under some circumstances it might be infinitesimally smaller bytecode generated here. It's not really clear if that's true for all JVMs or all compilers these days, but it was true at one point. But I personally do it this way just because I like the simplicity of it. I like to be able to take a quick look and say, oh yeah, it's grabbing the lock. And but you know, as they always say on commercials for cars, your mileage may vary. So if you don't like it that way, then by all means, don't feel like you have to do it that way. Is there a preference for volatile or handling access using unlock lock mechanisms? Mirzad, that's a great question. So my general rule of thumb is to avoid using volatile unless there's a really good reason to use it. Like if it really is a case of just being able to set and retrieve values atomically, then it's perfectly fine. If you're going to have to use locks anyway, then it seems to me using volatile is kind of a belt and suspenders approach. We have an expression in English called belt and suspenders. So if you really don't want your pants to fall down, you wear a belt and you wear suspenders. So now you have twice the opportunity to keep your pants from falling down. So making something volatile and then using locks on it is belt and suspenders. So my general rule of thumb is if I need to use lock operations to guard access to data members, then I don't really want to make them volatile. But if I'm going to use data members without requiring locks around them, then using volatile is a perfectly acceptable thing to do. Oh, here's a good question. I have never used volatile. When would you want to use it? You want to use volatile when you want to make sure that threads are able to see a common version of data. Let's take a look. Well, we'll take a look at a little bit later when we see some other examples. Volatile turns out to be unbelievably important to use. In fact, this is probably a good time to talk about volatile. So there's a question that's been floating around on the mailing list, or sorry, on the discussion board for several days now, having to do with the semantics of locks in constructors. And let me go ahead and show you the issue. So I alluded to this earlier when I said we don't need to make m-value volatile, and we don't need to do any locking operations in the constructor. Well, if you take a look on the discussion forum, there's a very, very, very long thread with a lot of really smart people chiming in, trying to figure out where on earth in the Java specification it says that it's okay not to put locks in constructors. And the basic issue there is if you create an object, in fact, let's be very, very, very concrete here. Let's go look at the test code. Let's see, where's the test code? Here's the test code. So if you come down here, I actually made a change to the test code a couple days ago, and I'll explain why. But here's what I had originally. Originally, we had something called simple atomic long multi-threaded test.java, and it had code that looked like this. It defined a simple atomic long M counter as a static, and then it spawned a bunch of threads that went ahead and ran, and you take a look, it spawns a bunch of threads and starts them up and so on and so forth. So all these threads are running. And the tricky question is, because M value is not the M value, this guy right here, because M value is not a volatile, and because the constructor has no locking operations, there's no obvious happens before edge that ensures that the value of this simple atomic long will get correctly propagated to all the threads that are starting up and running. We don't know if that's actually going to happen or not. And it turns out all the smart people on the class who were trying to figure this out from reading the Java spec had a big disadvantage. The Java spec as written today is vague on this topic. It doesn't really give the semantics in the spec of what happens to constructors. So after reading some of this stuff and looking myself and realizing that I didn't have a big enough brain to know the answer, I picked up the phone and I called my good friend Doug Lee, who's a very famous Java concurrency guy. He wrote a lot of the code in Java util concurrent and Java util concurrent lock. He's the author of several great books on Java concurrency, just a world expert on Java. And I said, Doug, what's going on here? Why are people confused? And he laughed and he said, because the spec is vague. He said, we're in the process of fixing the spec for Java 9, and in Java 9, we will have the semantics be that there's an implicit memory barrier at the end of a constructor that flushes its state out to other threads. He said, but right now, we don't have that, and so it's not surprising people are confused. And I said, well, what's the pattern? What's the solution to this? And what he said was, make sure whenever you have something that you need to make sure will be consistent, that you make its enclosing object be volatile. So here's a good case where we came back and I added volatile to the definition of simple atomic long for the M counter data member. And by putting volatile here, that ensures that the object state will get correctly flushed to all the different threads that are going to be accessing it when they start to run. And so as a result, we don't have to make the data members volatile in simple atomic long. We don't have to put a lock in the constructor for simple atomic long. We just have to make the simple atomic long data member volatile. And he said, until we fix the spec to clarify this and the virtual machines and compilers and so on do the right thing, that's the best way to do it. So this illustrates a whole bunch of interesting things, right? It illustrates how specifications are written by mortals, even people as smart as the folks who did it, and they sometimes don't remember all the different corner cases, so they have to be evolved. It also illustrates the fact that very smart people can argue long and hard and still not come up with the right answer based on the spec because it's incomplete. And it also shows why we need to be able to update our solutions as the class unfolds, because this is something that I certainly didn't know about before a week ago or so, and now I do. And the solution turns out to be quite simple, of course. We just go ahead and add this value, make the simple atomic long volatile, and that will solve the problem, so to speak. But lots and lots of really interesting things that came out of that discussion with Doug, and I'm incredibly grateful to him for taking the time to kind of walk me through that, because it's extremely subtle. So to answer Arjun's question, that's a great example of using volatile. You use volatile to make sure that the value of that object is propagated to all the threads that want to access it, and you don't have them getting incomplete state, which is a darn good reason to do that. Let's see. One of the evaluations, all the methods we're calling the get function. Oh yes, that's great. So here's, let me show people what it is that you're talking about. This is a fun example. This is also perhaps falls under the category of belt and suspenders type of issues. And I think this is a good example of where people's hearts are in the right place, right? But they're trying to do refactoring. So what they're trying to do is they're trying to do something kind of like this, where they would say, you know, m value plus plus return get, or something like that, right? That's kind of what they're trying to do. They're trying to say, hey, I wrote this thing, this accessor method get one time, and I want to use it everywhere because I don't want to have to repeat the code. So I think that's what you're talking about. Well, not surprisingly, what happens here is that this guy grabs a write lock, and then he calls get, and get calls a read lock. And yes, it's a reentrant lock, but there's overhead involved, and so the solution is, of course, very slow. Now, is that solution wrong? No, the answer is it's not wrong, it's just slow. So in that particular case, I probably wouldn't take any points off. I would leave a comment pointing out that it's unnecessary to do that, but we're really trying to encourage people to write thread-safe code, and man, that code was thread-safe to a fault. I'm much more concerned about the solutions that were actually incorrect. For example, the ones where people acquired the write lock, updated the variable, released the write lock, acquired the read lock, and then returned the value. That actually is wrong. So I would take points off from that, but I would not necessarily take points off from get. By the way, there's a pattern called the thread-safe interface pattern that appears in the POSA 2 book that talks about this issue and talks about ways of writing code to avoid this problem. Okay. Great question. Here's another question from John, or a question from John. By making simple atomic long volatile, do you still need to use the read-write locks at all? The answer is yes, because all that volatile does is it says a single read or a single write to memory will be atomic with respect to the caches of other threads or cores. It doesn't say doing operator plus plus or operator minus minus is atomic. And so as a result, something like operator minus minus looks atomic, but in fact it's actually doing multiple instructions. And so volatile is not protecting any of those. So you still have to use the write lock when you make the change. You wouldn't have to use the read lock, but you'd still have to use the write locks anytime you modified the value of m value. So yes, you can't get away from that altogether. How should we grade code without try finally block? As I showed you in my walkthrough, not a problem at all to use try finally. It's not a problem at all not to use try finally as long as the code is correct, right? You have to make sure that you properly do not return the values at the wrong time. Let me show you another example of code that would be incorrect from this point of view. This might help you a little bit. Let's see, we need to find our good friend Emacs again. It's funny, the Google Hangout stuff is really cool, but every once in a while it kind of flakes out a little bit. Okay, so let's go ahead and look over here. I'm trying to find another example where we can show incorrect code. So, like, here's an example of what you don't want to do. You wouldn't want to do something like this. I'll pick on this guy again. Something like lock minus minus m value, unlock, return m value. So this would be an example of not using try finally that will get you in trouble because you're actually reading m value without the lock being held. And that will cause you no end of problems because of the race conditions that can occur there. So it's fine if people don't use try finally, but if they don't use try finally, then you have to look more carefully at their solution to make sure that there aren't other subtle bugs in their code. And by the way, it's probably worth pointing out that this is a good example of why it is the case that we like to use try finally, even though it may not always be strictly necessary, because subtle programming mistakes are much more easy to spot if you use try finally. If you don't use try finally, you have to look very carefully at the code. Why is that? Because once you use the pattern of try finally, then a lot of silly accidental complexities kind of go away. All right, another question. When to use volatile and synchronize? Hopefully we've explained that already. Volatile basically gives you protection for reading and writing. Synchronized, I assume that you mean the word synchronized, like the synchronized block or synchronized keyword. Those things are used when you want to protect the blocks of code or the methods with synchronized access, which basically are write locks. So they're used to protect regions of code that may have multiple operations that need to be protected as a critical section, whereas volatile just protects reads and writes. It's a much simpler concept. You could almost think of volatile as like the ability to put the word synchronized on a keyword, on a data member. If you could have a data member be synchronized, that would be like volatile. Is it a problem if I create a read and write lock global for all methods and use the same objects throughout? I think what you mean by that is that you declare data members inside of simple atomic long that are the read lock and write lock members, and then you go ahead and pre-initialize them in the constructor or in the data member portion. That you can certainly do that. That's just a classic time-space trade-off. There's a whole discussion about that on the message discussion forum. Can you show the execution steps for the try finally block? Which line would run first and which line would run last? Yeah, sure. In fact, this is a great question because this gets to the heart of why the two solutions we looked at are basically identical. When you see code that looks like this, let me ignore for a second. Let's comment these guys out. When you see code that looks like this, what it's really doing under the hood is it's really doing this under the hood. And so what it's doing is it's coming along here, grabbing the lock, it executes this line, then it unlocks the lock, and then it returns the value. So this code here is really essentially equivalent to this code here. So this is really quite simple. Just, you know, if you're confused about try finally, just go look at the Java documentation for try finally, which is very easy to find, and it explains it nicely. All this does is it says run everything in this block of code. If no matter what happens, execute this finally block. So whether an exception is thrown, you return, or whatever, this unlock method gets called. So it's just a way of ensuring that cleanup takes place. If this was C++, of course, we would use a destructor and the scoped locking idiom from POSA 2 to do that instead. Let's see. Oh, Roman. So yeah, the other day I made a minor change to go from curly braces in one place to curly braces in another. That first of all, you don't even have to update your repository if you don't want to. Those changes were not things that affected the shells. You can certainly keep with what you've got. I would suspect that would take about 20 seconds to fix. If you write code in a professional environment, then you're forever having to do merges, and that should not take long. So that's just one of those things that's going to happen from time to time. But if there's something really important that you need to update, I'll let people know. But that was just a voluntary thing. Let's see. One student used lock in all methods. What kind of a lock is used in that case? That's a good question. I'm not sure. Maybe it's the monitor lock that comes with all objects. That's the only thing I can think of. But that's probably not actually correctly implementing readers-writers locks, is my guess. So is it incorrect to call the get method inside of increment and get? It is not incorrect. It's just slow. If I was working in a commercial project and I was reviewing code by another developer and they had done that, I would probably go and you know, twist their arm until they fixed it. But it doesn't make the code wrong in the sense that it creates the wrong result. It just makes the code slow. Now, there of course are situations where slow equals wrong, but that's just a matter of education. So let's go light on people who did that. They were trying, I think, to do a good job of refactoring and just didn't know the subtleties of that. If the returns, oh yeah, this is great. Thanks, Al, for reminding me of this. If the returns in both try and finally takes precedence. This is one of the reasons, again, why it sure would be nice if Java had destructors, because you wouldn't have these insane issues. But there was a funny thread on the discussion forum where basically, I won't be able to pull this off the top of my head, but basically somebody did something where they returned something here and then they returned a different value here, you know, or whatever, like this. And the actual return here is the return from the finally. And I personally think this is just absolutely pathologically strange, but that's the way that the semantics work in Java. By the way, I am not about to try to start getting in a philosophical debate about whether try finally is pretty or ugly or cumbersome or great. It's just the typical way you do it in Java. So you just have to learn, like so many other things in life, to just get over it. I'm not going to try to defend the design decisions they did, but it's the way that most people tend to do it. In which case is a race condition more problematic? 2 threads running in 2 cores modifying an object attribute, or 2 threads on 1 core doing the same? That's a really great question. When I teach concurrency and parallelism to my students, I always tell them that the main difference between a multi-core processor and a single-core processor is that a multi-core processor reveals the bugs in your multi-threaded code much more quickly than a single-core processor will. That's the main difference. And the reason for that is that things actually do run in parallel. Whereas with a single-core processor, sometimes things won't in fact run in parallel, and just by some quirk or magic, or you're born under a good sign, or you threw salt over your shoulder, or did not walk under a ladder, or whatever superstition you believe in, you turn your beer bottle the right way during the playoff games or whatever, things will work for you, but they're wrong. And so the bottom line is that you'll undoubtedly find bugs with multi-core processors that are there anyway much faster. So that's why it's always good to run things in a multi-core environment when you test it. So is a return after the unlock always wrong? Not quite sure what you mean by that, but the answer is no, it's not always wrong at all. In fact, the solution that I showed a number of times had us stash the M value into a local value, unlock the lock, and then return the value. So you just have to make sure that what you're returning is something that's not going to be contended for by other threads. And the easiest way to do that is to stuff it inside of a local variable. If you read the Java concurrency code, you'll see lots of examples where they do exactly that. So it's not wrong, it's just another way of doing it. In fact, that's what's going on under the hood when the Java compiler generates code. Does that mean return m value plus plus is the same as m value plus plus? Let's see. Okay, I think so. This is from Wa. So the question here is, if you have a try finally block, say we're inside try finally, and we say return m value plus plus, which is going to take the current value of m value, return it, and then increment the result after logically after the return is done. Is that the same as incrementing the result? No, well, it is not the same, because it's a post-decrement, and what you showed there is actually a pre-decrement. All right, let's see. What if somebody does not use try finally? I think we've answered that. If that's still a question, let me know. Is a program with just one class and an inner class according to solid principles? Can I use the dependency injection principle to pass inner class objects to outer class constructors as parameters? Luis, you probably want to type that up and put it on the discussion forum. I'm not entirely sure what it is you're asking. Maybe what you're asking, let's see, pass an inner class object. It sounds kind of like you're talking about callbacks. Maybe that's what you're asking. But why don't you type up that code and add it to the discussion forum, and I'll try to answer it there. Can any exception really be thrown in here? So I think, Victor, the question is, if we're doing things like m value plus plus or plus plus m value, will those things ever throw exceptions? No, those will not throw exceptions. That's because operations on built-in types that are plus plus and minus minus will not throw exceptions. But that, of course, is a very narrow range. Okay, here's a question about services. Why do services not block the main thread, although by default they do not run in a separate thread and perform all the computations in the main thread? So Deepak, services indeed will block the main thread. If you make a service and you sit there and go into a busy loop, or you sit on a semaphore or do something, then the service will block indefinitely on the main thread, which is going to cause an application not responding error. Then this coming week's videos will be on services, among other things, and we'll talk a lot about this. So the easiest way out of this is simply to use the intent service, which basically uses a command processor pattern to run the processing of intents in a background thread. That's the easiest way to do things. We'll also have a number of programming assignments later in the course that will give you a chance to do a bunch of different concurrency models with services, thread pools, free threading, all kinds of other stuff. So if services will in fact block the main thread unless you run them in a separate process. You can also run a service in a separate process, which of course will not block the main thread. Why do we have more assignments about Java concurrency and so small assignments on pattern software architecture or Android backends? So Roman, you just haven't stuck around long enough in the course. There's lots and lots and lots of assignments coming up on Android concurrency. I just haven't released them yet. We're still working on the unit tests for them. We're doing tests with Robotium. There'll be some examples that'll be coming out that'll be in the videos starting Monday, and so you'll see that the bulk of the assignments in the course are actually Android concurrency assignments. Why do we not do those first? Well, if you've been watching the discussion forum and seeing the struggle that many students have to do things as simple as a simple atomic long, or spawning threads and doing the array blocking Q test stuff that we did in assignment 0, you will very quickly understand that if we jumped right into Android concurrency, very many people's minds would hopelessly explode and they would probably drop the class in frustration. So if you already are an expert at the Java concurrency part, then you might want to kind of watch ahead and look at the other videos. And there will be other stuff that comes along here shortly that will go into a lot more detail. But the reason we do this is because I don't want to end up in a class where a lot of people get really confused and frustrated right off the bat. I would rather have everybody think, I'm making progress, I'm doing well, even if some are thinking I'm kind of bored. By the way, if you are bored, take a look. I think it's, we'll go bring it up. I will go show you exactly where it is, and then you won't have to guess. I anticipated that some people would find the assignments a little bit too easy, at least the first ones. I guarantee you, you will not find the later assignments easy unless you're already an expert, in which case, why are you taking this course? Let's see, easy. I think that was the thing I want to search for. Here we go. If you take a look at the FAQ, one of the questions is, the introductory assignments are too easy. What can we do to make things more interesting? So I would recommend you either work ahead and do the later assignments as we release them, and or go ahead and take a look at the assignments from my CS 282 course, which are on the web, which are available here. And you can take a look at them there. In fact, some of these assignments are going to be recycled in the MOOC. And if you are bored out of your mind with things like atomic locks and simple semaphores, go sink your teeth into some of the stuff there on different concurrency models and services and other stuff, and you will be less bored very quickly. And we'll cover those things later. How many assignments are there going to be in all? Well, you can find the answer to that question very quickly. Let's go over here. My goal in life, if at all possible, sometimes this is easier said than done, is to try to have the answers to most questions appear somewhere on the website, so I can just point people to the website without having to repeat myself over and over again. Whoops, just opened up the wrong window, sorry. Let's see, need to find a web browser to share here. There we go. All right, so if we go here and you go to the class website, which at this point I have pretty much bookmarked, and you go take a look at the statements of accomplishment link. This tells you what you have to do to get different kinds of certificates or statements of accomplishment, and it says somewhere in here, down here, let's see, you will have N programming assignments where N equals 8 or 9 by the end of the course, including the I Remember app, which is probably going to be 9. And therefore, it's possible to miss a couple of assignments or to do poorly on a couple of assignments and still be in perfectly good shape to pass the course as long as you do well on the other assignments. So it looks like we're going to have probably 9 assignments The idea is to try to keep each assignment relatively self-contained. We had one assignment that had several parts to it, and rather than giving that as one assignment, we broke it up into 2 assignments. So that's kind of the current plan. So for those of you who are worried that we will not have enough Android, you will have lots and lots of Android. Let's see. So there's the question here about get, where we're acquiring the lock, and that does in fact look correct to me. Hemanth, that looks fine. For what get was needed if we acquire a lock and setting, getting in value. Not quite sure, Roman, I understand your question. Please try re-asking that one, Roman. I didn't understand the question about the get. In one of the optional lectures, you mentioned that singletons should take into account concurrency. Ah, yes, yes, yes. How do you propose to control the concurrency in the get instance method? So I think Guillermo asked this question. Not sure which get instance method you're referring to. Is this an Android method? Let's assume it's an Android method. I recommend, if you're curious about this, take a look at the double-checked locking optimization pattern. I will. This is one of my major contributions to computer science, if I may be so bold as to say this. Let's go over here and type double-checked locking optimization Java. And here we go, double-check locking optimization. Go look at Wikipedia, which is the source of all wisdom in the world today. I wrote a pattern in 1996 or so called double-checked locking optimization. And this pattern was put in for a particular reason, to fix problems with singletons and their use in concurrent programs. And it was very cool. And over time, people began to notice that as the instruction sets of hardware changed, this pattern was having some weird side effects in languages like Java. And so if you take a look here, you will learn all you ever possibly wanted to know about double-check locking optimization. And in fact, because I wrote this pattern, they discovered there was a hole in the virtual machine specification. And many, many smart people, again, many people way smarter than me, have written about this extensively. My favorite example is from some folks at IBM and Maryland who have done some really cool work on this. You can see this, some examples of double-check locking, and they basically ended up fixing the Java spec to make things worse. Make things work, not worse, but work. So double-check locking works in Java now, and if you watch those videos, it will go into some detail about how to implement double-check locking. And you might want to take a look at that. If you don't find it in those videos, let me know, and I'll point you to the place where it's actually covered. Have you finished showing the solution of assignment 1? Yes. Nurin, if you have other questions, don't hesitate to ask, but you can go back and watch the video if you had any questions that I didn't cover. Let's see. So here's a question from Paolo. There's a whole bunch of ways to do double-check locking equivalents in Java for multi-threaded programs. If you read the double-check locking Wikipedia page and read about Java, you'll find there's a whole page about double-check locking and synchronization for singletons there. Lots of different approaches that are gone into in great, great detail. When you return within a try block, is the finally block automatically performed? Yes. The answer is yes. Even if an exception is thrown, which is why they're cool. Let's see. Here's a question from James. It's hard to read code question, James. So please go ahead and post this on the discussion forum, and I'll. The screen I have to read here is minusculely small. Why assignments are not reinforcing what we learn in the video lectures? Well, actually, everything that we're covering is, in fact, based on what's in the videos. In fact, if you read all the assignment descriptions, you will see that for every requirement that's discussed in the assignment description, there is a reference back to the appropriate video to go watch to learn from that. So I'm not quite sure what you mean about not connected to the content in the video lecture. We are not having videos, formal videos, that walk through the assignments But the reason we do that is because we have virtual office hours, which are identically the same. So what I do here is I create videos in virtual office hours where we walk through the assignments piece by piece, and I talk about them, I answer questions. If people have questions, they can post them to the forum. So that, in my mind, is actually a much more useful way of being able to do this than trying to record formal videos talking about assignments, which would be absolutely mind-numbingly boring. And so this is a much more interactive environment because you guys get to direct where the questions go. Yes, I totally agree. Arjun, the fact should be required reading. I have to chuckle to myself because many times questions come up which inevitably are answered on the fact. Things like, do you need to know how source code control systems work? There's a whole pile of things that are up there about GitHub and Git. Those are things that people really should be able to learn. It's not that hard. Here's a tip for you. I recommend not trying to use the Eclipse way of integrating with GitHub. I recommend using a Git shell or a command line version. Really easy to use. I use like 4 commands for all that I do. I use git pull, I use git commit, I use git status, and git push, and that's about it. I mean, there's git add. I suppose I use git add too. But if you're reading my stuff, then you just have to use git pull, and that's about it. There's not a whole lot of other things to do. It's actually quite simple. Let's see. You're quite welcome, Roman. How to know what part of code needs testing. So I once went to the dentist, and I asked the dentist, Dr. So-and-so, which of my teeth should I clean? And he said, which teeth do you want to keep? So I would say, which code needs testing? Which code do you want to run? Which code do you want to increase the likelihood of being correct? Well, I think the answer is pretty clear. You need to test stuff as much as you can. In real programs, in real systems, you of course would have regression test systems with continuous integration. You would do all kinds of things in order to be able to have coverage of your code. You would have tools that would tell you what code was covered and what code was not covered. And if you really cared about it, you would use the static and dynamic analysis tools we were discussing earlier to be able to do instrumentation and annotations and modeling. And the more mission critical your code is, the more important those things are. Obviously, for a class like this, we do the best we can with absolutely shoestring budget. But in real life, when you actually have a budget, you should do a lot more. If someone read and writes separately, should we deduct a point? I think if people did reads and writes separately and the answer will be wrong, that should be a point deducted. If they did a correct downgrade of the lock, then you don't take points off, but I bet very few people, if anybody, would have done that because it's incredibly complicated to get right. So yes, if the code actually will return the wrong results, then I would say it's not correct, because that was the whole point of this, to make sure that synchronization was right. In week 3, we learned about handlers, but the assignment's about semaphores. Well, I don't know what to say. Wancho, we're doing the best we can. A lot of this material is being created in real time, and so when we offer the course again and have the luxury of looking back on things, undoubtedly we'll do them differently. But at this point, if you are bored with stuff, then just go ahead and work ahead on the assignments, and by the time we get to them, you'll be one step ahead. Talking about handlers, why do they have to post messages and runnables to the looper while they were intended to them? Is it because they are encapsulated and must be dispatched by the looper? Okay, so Pierre is asking a question about handlers. So I think what you're asking there is, how is the underlying message passing infrastructure of the Hammer framework implemented or designed? I think that's the question that you're asking. And if that's the question that you're asking, of course, take a look at all the videos that go through that. But basically, what they're trying to do here, and it's somewhat complicated to understand because the pieces are not very cohesive. As I say in the videos, they are loosely connected. So as a result, what they're doing is that you're posting or sending a message from one thread to another thread, or from one thread to itself, right? Both those models work perfectly the same. In fact, the implementation is pretty much identical. And so when you invoke an operation on a handler, it takes the message and it sticks it on a queue that is managed by the owner of the looper, which might be another thread. And when a handler is created, it's always created in an owner thread. You can also pass in another thread's looper when you create a handler. This coming week's videos will show that. But basically, they do this so that they can end up having a message pump that can be used to single thread the processing of the messages. So I recommend you go back and watch the looper video. The looper video is really the one that explains the underlying event processing loop that's done in Android for all this stuff. It all comes from Looper. Oh, people want to know the analysis tool. Oh, great question. So let me get a browser up here, and I will show that. Nope, that's not a browser. Here's a browser. Let's go get a browser. So the modeling tool that I was talking about that's really cool is called Fluid, and it's at www.fluid.cs.cmu.edu. If you go there, it'll bring up this page, and the company that's an open source tool, and there's a company called SureLogic that provides a commercial supported version of this, and that was the tool I was talking about. And hopefully by the time we do this again next time, we will have had a chance to add some more cool stuff, and we'll be able to have Fluid integrated with this, if all goes well. We'll see. We're unlocking the lock first and returning the value. What if the value changes between the unlock and the return statement? Well, as long as you've copied it into a local variable, then you don't have an inconsistent result. The result may not be the freshest result, but it's not incorrect, and it's also not inconsistent. It's not corrupted. You're not getting half of a result. And that's all atomic long or atomic int or simple atomic long is promising. It's just promising, I will do the updates atomically. So that's perfectly fine. That's just the nature of concurrent programming. So there's no problem with that. Let's see. Wancho, not a problem? Let's see. Oh, condition objects. Can we discuss condition object? Where to properly initialize the condition within or outside it when used with semaphore. So we'll take a look at that in just a second. I'm going to show you that assignment in just a minute. All right, another question. Why do you put in the solution the final for the argument of your constructor, which is passed by value? If you call 2 or more times, is it going to return you all the time the same instance? Let's see. Oh, I think I know what you're asking. Let me go flip over here real quick and see if I can find this particular thing. Let's see. So I think you're asking, why is final here, right? Why is there a final there? Well, strictly speaking, it's not necessary. It's in there as a documentation aid that just indicates to someone reading the code that this value is not going to be changed within the scope. It's almost like if this was a C++ program, we would say const. That's basically what we're using in that context. That's just a style that a lot of Java programmers like. I didn't really use it much until I started teaching this class, and a lot of people got excited about it, so I've been using it as much as I can. In week 4, assignment 3 skeleton, which is this coming week, the comments say acquire and release are hook methods. Does that mean they're somehow called by an external or inheriting class? Let's see. So in this particular case, they're probably not hook methods per se, although you could implement them as hook methods if you wanted to. That's a good question. Let me go over here and look real quick. Certainly in the next assignment, they will be hook methods, but in this assignment, they might just be good old methods. But let's take a look and see. We'll go over to POSA 14, assignments. So I'm going to change that. This will drive a few people crazy, but it's a good point. They're not strictly hook methods because we're not really subclassing from them in this particular implementation. Although you could subclass from them if you wanted to, but that would be overkill in this particular case. By the way, if you're curious, let's see if I can do this. So I just made a change to my code, and now let's go over here, and let's see if I can show you how I would go about using, how I would use my source code control system to do this. I would say git status, and that tells me that I've changed the ping pong right just a little bit, and I would say git commit, and I would say removed the term hook, since they aren't really being used as hook methods. Save that file, and then I just say git push, and there it is. That's pretty much all I do, right? So it turns out that using git is sort of ridiculously simple when you're using command line interface. I'm just pushing things around, committing stuff, checking the status, say git status, it's all clean, and so on. So I'm sure some people will get all upset now because I just made a change to the code, but that was a good comment. And so they really aren't hook methods in that case. Let's see. Some of these are probably left over from earlier. In a second, I'm gonna switch and talk about semaphores. Is it overkill to use read and write locks in operations like get and decrement? It's overkill to use read-write locks if all you ever do is update things. But since we needed to be able to do reads and writes, it wasn't really overkill because I wanted to be able to show the use of read locks and write locks. So get uses a read lock, and then the other ones that you mentioned here, James, like get and decrement, those are write locks. If you take a look at the actual implementation of all this stuff, of course, you'll see that they use a volatile and some lower level mechanisms, but I was just trying to show how to use reader-writer locks just for fun. Let's see. Oh, here's Prasan. Programming is new for me. If I fail to submit correct assignments, what will happen? You will probably not score very well, but it all depends on what you're trying to get out of the class. If your goal is to learn and be better at this kind of stuff, then I say keep going for it. You may or may not get a certificate with distinction, but that may not be important if you're new. By the way, just a general point, if you're brand new to programming, this would not be my choice of class to start with. It's going to be way, way, way too hard. Not because you're not a smart person or anybody's not a smart person, it's just a lot of very advanced concepts coming at you very quickly. So if you take a look at the POSA FAQ, you'll see that there's a suggestion for people who are new to programming, and there's some recommendations on other classes to take first. And once you understand that, then I think you'll be in better shape. So I would start with that. Let's see. There's an Android project, but the Eclipse doesn't import the folder when I choose folder of it. I don't know what the issue is there. I would just say don't import it as a, I would say import it as an Android project. I'm not sure why it doesn't work, but if anybody knows the solution, let me know. Is it necessary to use try finally when reading or writing? We've talked about that at length. Is it necessary to use try finally? We've talked about that at length. It's not necessary, but it's probably not a bad idea. Return. So why it is not the same as what you. Oh yes, yes. Wow. The second thing you put is correct. Yes. Pretty long office hours. It definitely is, but there's a lot of people with a lot of questions, so I want to address them. If the office hours goes on too long, when I upload the video, just go ahead and play it really fast, and so you can get to the parts you want. Why in the handle callback method of the handler class we are running the callback directly? So Dimitri, that's the way it's implemented. They borrow the thread of control of the caller to dispatch the callback. If you want a separate thread, then you're welcome to spawn one. That's not a problem. You can do that using some of the techniques that we talk about. But by default, the thread that runs the looper thread, is the one that does the callback, and that's where the callback takes place. So that's what it does by default. But you, of course, can change that any old way you want. Let's see, Sheila. I thought we had to return a value instead of m value. Take a look at the video. We talk about all the different ways to do it, Sheila. There's many roads lead to Rome if you're trying to go to Rome. Let's see. There's a question here about can you post your result from the JUnit with a local variable solution? Take a look at the video. It's all there. How many points would you take off? I've lost the context of what the question was. Let's see. What if final lock, write lock is a data member and they call lock in the method? That example, as long as it works, it's fine with me. That's just a time-space trade-off. Let's see. We have two kinds of get methods. One using read lock and calling get. So Elitza, as long as they're giving the right result, that's what's most important, as long as the code is not impenetrably impossible to understand. Lock and reentrant lock are the same. No, lock is an interface, and reentrant lock is an implementation of that interface. There can be other locks besides reentrant locks. Let's see. Okay. Updating the M value and then reading it with a read lock does not produce an error with JUnit. Doesn't surprise me. JUnit's not really intended for this. We're doing the best we can with it. You'd really need a more powerful analysis tool. Why is reading the value after updating with a read lock incorrect? Because you're not guaranteed to have serialized access. And the minute people start doing multiple concurrent writes to an unprotected value, you're going to have corruption. Let's see. So what if M value is updated in try, but they call get after the try finally block? That's probably incorrect because there's a race condition, so that would be wrong. I have found many places over the web having multiple handlers for a single thread is often considered a bad design. Why is that so? Deepak asked that. Well, because you can end up in situations where you'll have different handlers behaving in different ways that may be inconsistent with respect to blocking semantics, for example. It may also just make the code hard to understand. I guess it's hard to answer that question without more context. As with almost everything in computer science, it's not a question of is technique X right or wrong, it's a question of what are the alternative approaches. A good example is the singleton pattern. There are downsides with using singleton. Not using singleton can often be more complicated than dealing with the downsides of singleton. So people have to be very careful before they start to overgeneralize from anything without understanding the context in which it was addressed. Let's see. Can you clarify the distinction between the atomic guarantee versus transactional guarantee? Atomic just says when something is updated, that update is done atomically. But it doesn't say that the second you get the result back, somebody else hasn't gone ahead and updated the value again atomically. Transactional would mean I acquire a transaction lock, I grab the value, and then I keep everybody else at bay until I'm done with the value. So I always know I have the freshest, latest value. And when I'm done, then I go ahead and release the transaction lock. Atomic lock or atomic long does not give you transactional properties. It just gives you atomic properties, which are sometimes useful and sometimes not. Transactional is a more powerful form of locking and, of course, has more overhead. Let's see. I think I understood you to say that lock interruptibly would be used in the try block while lock is to be used outside and before. It all depends on whether you want to catch the exception or not. There's plenty of situations where you actually don't want to catch the exception. You want the exception to be propagated up to the caller, in which case there's no sense in putting it inside a try block because you're not planning to handle it anyway. It's a shame that the current MOOC participants can't obtain an evaluation copy of Fluid. I agree. I'm going to be hopefully talking with them next week. It's probably too late, unfortunately, at this point to do something because we don't have a lot of resources to work on this, but we'll probably try to get it done for next time. We'll do the best we can. It's actually, this idea popped into my head this morning as I was driving to work, so it's pretty much late breaking. If you're optimizing, why do you do it inside get blah, 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 blah? I'm not sure, Elenda, I understand your question, but there's lots of different ways to solve this particular problem. Okay, here's a question. According to Section 1, Module 3, Part 2, 2 frameworks to avoid application not responding, hammer and async tasks. You mentioned that hammer is loosely coupled and async class are tightly coupled. Actually, I think I used the word loosely connected and tightly connected, not coupled, but connected. So, Luis, I am always very skeptical to base anything on reference to solid principles or any other kind of principle. I think things have to be thought through in a case-by-case basis. If you watch the video, which I think is Section 1, Module 3, Part 9, it's the last video in the series from Module 3. It goes through in great detail and discusses circumstances under which you would apply the Hammer framework or the async task framework. So I would be much more comfortable once you've taken a look at that and then re-ask the question than I am trying to give an answer based on some principles that abstractly don't relate to the particular situation at hand. If Fluid is open source, why can't we access it without support? You can. Nothing's going to stop you. People can do whatever they want with it. It's just that you would have to figure it out yourself. Are we going to discuss the assignment 3? Yes, we're about to discuss that. There's been a lot of questions here. After W2A2 submission, I updated my repository, and my previous successful code is no longer working. Okay, well, then you need to go back and take a look and see what might have changed. Let's see. Can you, Huckleberry asked a question, can you update the assignment description to make the requirements easier to understand? That's a pretty hard thing to do in the abstract because I don't know which of the assignment descriptions you're talking about. But if you want to post on the discussion forum some specific things that are confusing to you, I'd be happy to do that. Although, honestly, it's probably better to ask the questions in the virtual office hours than it is to try to figure it out by reading almost any requirement. Okay. I think we're almost done with the questions. That's pretty cool. In the constructor simple atomic long, do we have to protect the initialization of M value? No, you don't. We talked about that. All right. I think we're winding our way out of the questions, and then I'm going to go ahead and talk about the next assignment real quick. Just trying to get cleared up. When should cyclic barrier be used to access a writer lock? Ron, I would not use cyclic barrier to access a writer lock unless I had a really good reason, and I can't think of one off the top of my head. What is the default visibility of a method? I believe it's package public, but rather than trying to leave it to people's devices, I would always try to be explicit if possible. I try to do that when I write code, even if it's a bit more verbose and unnecessary. All right, I think we are almost done. Sorry, there's just been a lot of questions, but that's good because that means people are interested in learning, which is great. Can there be a glossary? There absolutely should be a glossary. If there's not a glossary, I know some people had started the glossary at one point. The place to put the glossary is on the Wikipedia page for the class. If there's not one already there, you should start one, and people can enter questions that they have, and other students will help to flesh that stuff out. Oh, here's a great question. If someone is mistakenly downgraded, what is the process to recover the missed points? There is unfortunately no process for that. If you take a look on the POSA MOOC FAQ, one of the things it says is, what is the consequence of the massiveness of the course? And right now we have 75,000 plus students, and so being able to go back and regrade everybody's assignment that is not happy with their score is quite tragically well beyond the scope of what we're able to do with the incredibly meager resources we have, which is mostly me and a couple of my grad students and undergrads. So we're not going to be able to do that. I'm very sorry, but it's just not possible to do that given the resources. If we use the Hammer framework with 2 threads, T1 and T2, each thread has its own looper and its own handler, but only a unique message queue for both threads. Is that right? No. If you have, well, it depends. If you have each thread that's a handler thread is going to have its own looper, and so if you watch the videos, you'll see how you create a looper thread and so on. And so they will have their own, they'll have unique message queues for each thread will have its own message queue. If you go back and watch the video and don't understand that stuff, post a message to the discussion forum and I'll answer it. Is there any penalty for retaking quizzes? No, you can take the quizzes as many times as you want, up to 100 times, believe it or not. And if there really is no good reason for not getting a perfect score on a quiz other than just getting tired of taking it over and over again. The goal of the quizzes, quite frankly, is to help people learn. So we could have made it a lot harder. That wouldn't be difficult at all. But we wanted to make something where people would be inspired to go back and watch the videos. Okay, let's now talk about assignment number 3. Sorry, week 3, assignment 2. So here's the assignment description. And maybe this is what the question was about, making it less confusing. If so, feel free to go ahead and ask. Let's see here for a second. Okay, so this is basically the Palantir program. By the way, I have to say something kind of funny. I think it's amusing that if you're a Lord of the Rings fan, then Palantirs are used to communicate over great distances between people. And in some sense, Google Hangout and Hang On the Air is like the Palantir. I don't know whether that makes me Sauron or everybody in the class Sauron. I'm not sure. But basically, the idea here is we have a program that's going to test whether you can write a simple semaphore. And here's what the simple semaphore looks like. You go ahead and put a Rantrant lock here, which if you watch the videos on condition objects and watch the videos that we have on the some other examples, you'll see how to use the Rantrant lock. Then you define a condition, and the condition is basically an interface that's initialized by a factory method on Rantrant lock called new condition. And then you go ahead and you put in a count of the number of available permits. And my recommendation would be to make this volatile. You don't have to do that, but that would be one way to do it. You can also put locks in the acquire permits method. Here's the constructor for simple semaphore. You have to go ahead and initialize it. It's really quite straightforward. You go ahead and basically make a new condition and initialize that data member using the new condition factory method that's part of the Rantrant lock that you created. You go ahead and set the use the permits to give the number of the available permits. You assign the number of permits you're going to start with, and then you also need to pass in the fair parameter to the Rantrant lock when you create it. So that way you can create both fair and non-fair semaphores. So that's how a simple semaphore works. Acquire is pretty idiomatic. All you do is you have to acquire the lock, and then while the number of permits is equal to 0, you're going to wait on the condition. And this particular acquire method, as you can see, is one that acquires things in an interruptible way. And so you have to make sure that you lock and wait in an interruptible way. And when you're awoken later, when someone releases a semaphore, if it's locked, then you're going to have to go ahead and recheck to see if you've got the permit count that's greater than 0. If you do, you will go ahead and decrement it by 1 and release the lock, and then you're out. So that's how acquire works. Acquire uninterruptibly works pretty much like acquire does. It just can't be interrupted, so it makes calls to lock and await as opposed to lock interruptibly and await interruptibly. And then release acquires the Rantrant lock, and it comes in there and it goes ahead and it increments the count by 1, and it signals the condition to let any waiters know that there's now an additional permit available, and then it releases the lock. So that's basically how you do that. All those pieces of code are very short. If you read on the web, you should find out explanations of how they work. Available permits is just going to return the count of the number of permits that are available, and if you use a volatile memory field, then you don't have to do anything. If you don't use volatile, you have to acquire and release the lock. So either of those ways works. That's basically simple semaphore. Simple atomic long is just basically cutting and pasting your solution from assignment number 1, not assignment number 0, assignment number 1, and after updating anything that you were inspired and learned and motivated by my discussion of my solution. The reason that we're doing this, of course, is to give people a taste of writing reasonable code and maintaining code, and then making sure that they live with the enhancements they either add or don't add based on feedback and seeing other code that's correct. So I'm giving people a taste of reusability. So those are basically the only things you have to do. There's a test suite that is pretty cool. You don't have to understand it really in order to be able to make it work, but basically what it's doing is it has this thing called a Palantir. For those of you who are Lord of the Rings fans, a Palantir is this magic seeing stone, kind of like Google Hangout, if you will. And you can gaze into Palantirs, and they also have names. And we have a thing called a Palantir Manager, which basically is given a list of Palantiri, and it then hands them out to people who want them. And there's only a limited number of them. So in our case, we have 3 of them. And so it's basically a resource manager that we use to hand out Palantiri. And then we have a unit test that goes ahead and spawns a bunch of threads, and it spawns a separate thread for each potential user of the Palantiri. And as you can see, there are 5 potential users of Palantirs. And we only have 3 Palantirs, however. We have a limited number of resources, and we have a larger number of threads that want to use them. And so once the threads are all started up, we go ahead and have them try to acquire the Palantir. And if they get one, then they go ahead and they gaze for some period of time. And when they're done, they release it. And the main workhorse method here that does all the interesting stuff is this runnable called use Palantir. And it runs in a separate thread, and it iterates for some number of times. And it goes ahead and tries to acquire the Palantir. And then it does a little bit of checking to see if you've done the fairness correctly. This is not 100% precise for reasons discussed in the comments. And we also keep track to make sure that you actually have implemented your semaphore correctly. If you have implemented your semaphore incorrectly, you'll end up trying to get too many Palantir, more than are available, and that'll cause an exception that will cause your system to return incorrect as the result, hopefully. And then you gaze in the Palantir for some random amount of time, or actually some fixed amount of time per Palantir. And then when you're done, you go ahead and release the Palantir. And you can see that we use the simple atomic long in order to increment and decrement the Palantir count to keep track of these things. Okay, so that's basically an overview of the assignment. The whole thing really comes down to understanding how condition variables work. Make sure that you watch the condition variable video. Make sure that you also watch the video about Java synchronization and scheduling mechanisms, because that shows how to use condition variables in interesting ways. I think that is that. If there's any questions, feel free to jump in and ask them. Let's see. For assignment 3, I used the volatile counter. That's perfectly fine. That's how I do it. Yeah, so Pierre brings up a good point. One of the great things about concurrent programs is they are hard to debug. You pass all the tests, but you feel something is wrong. Well, clearly, Arjun, as you've seen if you've been following the discussions on the discussion forum, the passing the unit tests is a necessary but by no means sufficient indication your program is correct. There's all kinds of other things that can go wrong, and so it's just there to help winnow out the things that are obviously wrong. We would have to use much more powerful static analysis and dynamic analysis tools. I totally agree with Arjun that Lord of the Rings is great. I love it. Can we make the semaphore non-fair for Sauron and fair for others? That's very good. I like that. The real question I have to ask, though, is how does Sauron actually look in the Palantir if he is simply a lidless eye? How does he hold it? So that's always sort of flummoxed me. Let's see. Donald, great. Glad you're in Irvine. I love Irvine, one of my favorite places. Do we really use a long to increment and decrement the Palantir versus a volatile int? Well, Del, there's 2 answers. First, we're just using, since we spent the time to write the simple atomic long, we wanted to find a way to use it, so that's probably the main reason we're using it. But it's important to note that you could not use a volatile int and increment and decrement it and have it work properly. That is not what volatile is good for. Volatile is only good for reading and writing atomically, but is not good for incrementing and decrementing atomically. I don't have the same class for simple semaphore as you were showing on the screen. Well, I'm not sure what to say. That's the version that's in the GitHub repository, and actually I think has been there for quite some time. Why don't you tell me, Manish, what it is that you see that's different? Let's see. All right. I think we're running down here. I've submitted the wrong assignment file for assignment 1. What can I do now? There's not much you can do now. This is discussed as one of the FAQ entries. So again, due to the massiveness of the MOOC, we are not able to, and the use of peer assignment and peer assessment, we are not able to go back and reopen peer assessment to put other people in who missed the deadline. I'm very sorry about that, but it's just beyond our control. It's way, way, way too complicated for the amount of people we have to work on this. So the good news is, as discussed in the Statement of Accomplishment website page, missing an assignment is not going to hurt you very much because there's lots of other assignments you can do. Because of the different sleep times, it seems like Minas Tirith Palantir is gazed many more times than the others. Yes, that's correct. The different amount of gaze times will change the amount of time you can acquire and release them. Absolutely. That is very good. Okay, I think we are almost done. Let me do one more thing, though, because I promised everybody that I would also go and try to make sure that all the questions were answered on the virtual office hours website. So let me just take a quick shot at that. Obviously, people who have to drop off, I understand that. You can always come back and watch later if there's something we talk about that you miss. But there were some interesting questions here that I wanted to get to, just to make sure for completeness that I've addressed them all. All right, here we go. Let's see. All right, so Luis Andino, I will come back and answer your hammer async task question later. Since I don't, unless it's very short, I'll take a look at that in a second. Let's see. How to use principles in POSA in a simple example. Let's go. Let's start at the bottom. That's a good place to start. So scenarios using async task or handler messages. So I think I pointed out where to look for this. You can take a look at the Programming with Android Concurrency Frameworks Part 2, which has the last 3 minutes or so, has all kinds of information that compares and contrasts the various approaches and gives you one of another. Is inversion of control a pattern? Yes, absolutely. It's also really kind of a meta pattern because it's a pattern that's used in a lot of other patterns like observer, reactor, lots and lots and lots of things use inversion of control. It's basically the essence of what makes something a framework, and so there are videos on that. As I discuss in the response, if you want more information on this, go take a look at the videos from the POSA 1 course, 2013 POSA course, and there are a ton of videos talking about inversion of control and patterns for inversion of control that you should take a look. Let's see. Oh, when should I/O events be asynchronous? Great question. So bottom line is, in the half sync, half async pattern, the async stuff is meant to be run with short duration tasks. Things like handling an interrupt from a hardware device driver, or handling user input, or something in the user interface thread, or something like that. The synchronous processing is used for long duration tasks so they can block. And the main issue is that the more threads you spawn, the more overhead you incur. So if you can get stuff to run, quote, asynchronously or reactively in one thread, it'll probably be less consumptive of system resources. And so that's the essence of why we do put things in the async part. And that's particularly true in memory-constrained environments like an OS kernel. Acquire uninterruptibly versus acquire. When would you choose one versus the other? That's real easy. You use interruptibly if you want to allow other threads to interrupt what you're doing, which is sort of like, oops, I probably got this backwards. Yeah, let me fix this. Non-interruptibly is used when you don't want to be interrupted. So that's kind of like putting the do not disturb sign on your door if you're in a hotel or a bed and breakfast. You say, I don't want to be disturbed, so I want to be non-interruptible. Interruptible says, hey, come in and bug me. I don't care. I'm open for business. Kind of like if you have office hours. You don't want to be bugged by your students outside of office hours, but when office hours is on, they can come in and ask you any question that they want. Built-in monitors and producer-consumer problem. So basically, one of the lame things about built-in Java monitor objects is the fact that They really have to be notified using notify all because there's only one of them. There's only one wait set per monitor object in Java, built-in Java monitor objects, and that leads to all kinds of problems that are discussed here. So one of the nice things you get with condition objects is the fact you can have multiple wait sets, and then you avoid this problem. So that's one of the other motivations for using Java condition objects, and one of the reasons why they were actually added. Let's see. So, yes. So there's no reason that you actually have, if you don't want to get the updated version of these things, just don't do an update from that repository. Just keep what you've got. There's no reason to have to do it. I just did it to make things consistent, to avoid less confusions, or avoid confusions. Someone asked a question about sending and handling messages by an adapter. I didn't understand what was meant by adapter, so if that gets clarified, I'll answer it. Let's see. There was a discussion about various things. Oh, why are the patterns not all in Java? Well, the reason that they're not all in Java is that when I wrote those patterns and when the Gang of Four wrote their book, we were C++ programmers, not Java programmers. And the great news is all these patterns are still relevant, and in fact, people have taken the time to document them in Java form in many cases, but not everything we have is in Java, although we're working on updates to some of the books that will be in Java. So bottom line is you just have to be patient or go and avail yourself of other resources. Let's see. I think there's lots of questions here about the try-catch block kinds of things. Hopefully we address that by looking at the code. If not, let me know. Fairness ordering policy probably shouldn't matter. Let's see. Yeah, bottom line, you don't have to use fairness for the week 2 assignment 1. In fact, that'll make it run slow. How to use principles in POSA. Okay. Great. So I'll take a look at this offline, and we'll take a look at that. But this, at first glance, this looks not unlike the way lots of Android code is written. So we can debate whether they're good or bad patterns or idioms or so on. Great. Okay. Well, I think we've kind of gone way over. There are only 196 countries in the world. Well, you know, that's an interesting question. I think we have people from 197 countries in the world, so that probably means that people from the gray havens in Middle Earth are actually taking the course, and they are probably using Palantirs to communicate. All I do is just report, let's see. The Osgiliath Palantir was lost. Well, that's interesting. I always thought that the Osgiliath Palantir was the one that Sauron had, but maybe that was a different one. Any recommended book on patterns for Java? It depends on what kind of patterns you're trying to learn about. The book by Doug Lee on concurrent Java programming, or concurrent programming for Java, is a great book on Java concurrency patterns. And you'll also take a look, if you look around, there's a bunch of books on Gang of Four patterns for Java and other places as well. Let's see. All tests were successful, but exceptions were getting generated. So if you're getting exceptions, then your code is not correct. Surprise, surprise. I think simple semaphore constructor is not showing more to-do comments, just showing to-do. You fill in here. Yeah, Manesh, I'm not exactly sure what you're referring to. Why don't you post the version that you have on the discussion forum, and I'll take a look, and maybe you have to add a few more to-do comments back in there. But hopefully after the discussion that we had here, you'll know what you need to put in there. Okay, well, I think we've reached the end. I will go ahead and download this and post-produce the video, and we'll upload a new version shortly. Thanks to everybody for sticking around for almost an hour and 45 minutes. I know it's been a long time, but there were lots and lots and lots of questions, and I wanted to do what I could to get to as many of them as I could. Thanks again, and I'll look forward to talking to you more on the discussion forums.